Alright, let's look at the first topic now, torque and moment of inertia. Okay, torque is very similar to another word called moment. Okay, moment, if I believe you have heard before, it is basically a force multiplied by a distance. Okay, and this distance is typically a perpendicular distance. Okay, perpendicular to the direction of the force. Okay, for example, if you have a seesaw, okay, one person is on the left, the other person is on the right. Okay, it's causing a FA force downwards, but because of its weight, and then you have a FB force, right? And then the distance away from the pivot point, let's say is DA, and this would be DB lah. Okay, since the force is perpendicular to the distance, DB and DA is being used to calculate the moment. Okay, what do we look at? We look at which point, with respect to which point you are being rotating. So for this case, usually it's the pivot point here, right? So moment caused by A is basically force of A multiplied by dA. Okay, and moment caused by B is your weight of the guy multiplied by the distance away from the pivoting point, the rotating point. Okay, and there is a direction for moment. Okay, if you look at the pivot point and the force is acting downwards, imagine the ruler like this, right? The force is acting downwards with respect to the left side, to the right side, it is causing the ruler to go in the anti-clockwise direction. Okay, so this FD will cause a anti-clockwise moment. So MA is actually this direction. Okay, whereas for B it is causing the ruler to move in the clockwise direction. So MB is actually clockwise direction. Okay, a torque is the same thing. Okay, it is basically a kind of a twisting force. Imagine you have a tap at home. Okay, in order to let the water flow, what do? You turn the tap, right, in the anti-clockwise direction, right, so that the water will flow. When you want to close it off, you turn the opposite way. Okay, so you turn clockwise to turn it off. So that is applying a torque on the tap itself. Okay, some kind of a twisting force, if you say. And since it's F times D, the unit will be Newton times meter, Newton meter. Okay, that is the unit for torques. Okay, now we then look at the typical questions that will come out in this topic. Usually you will see that it consists of some kind of a cylinder or a shaft, a circular shaft, okay, being rotated either in the clockwise or anti-clockwise direction. And this drive shaft, right, is typically connected to a cable. Okay, imagine a cable carrying an object. Okay, so by turning, the object will either go down or go up. Okay, so that is the typical question. Okay, if you look at the whole thing in this direction, cross section, you can draw it this way. Okay, this is center of rotation, cable, object. Okay, if you pull it, you will go up. If you clockwise, you will go up. If you do anti-clockwise, you will go down. Okay, and what we do is we break this system up into two. The first part is the rotating component. Okay, the second part is the moving up and down part, which is the linear component. Okay, by splitting them up, you can solve the equations respectively. Okay, let's draw the free body diagram. The rotating component will look like this. Okay, let's assume that we are lifting the object up okay, and this is the linear component, the object like this. Let's assume we are lifting this up. So when we lift this up, our cylinder, our drive shaft should go clockwise. Okay, we are applying a torque to lift this up. So applying, so this is an applied torque. Okay, and how will the motion of the drive shaft be? It should also be rotating in the clockwise, right? So motion is this way. If motion is clockwise, the friction will be opposite of the motion. Okay, so the friction should be anti-clockwise. Okay, we call this TF. Alright, and then if you are the drive shaft, the object will always try to be pulling you down, right? Through a tension, right? So this is the tension force that is caused by this object lah. Okay, we call this F. Okay, so and one last thing is the acceleration. You remember sum of F equals ma, right? There's going to be acceleration, but this time it's an angular acceleration. I cannot write a because a belongs to this object. Okay, so something related here will be alpha, angular acceleration. These two are going to be related. Okay, later I will show you. So this one is your free body diagram for the rotating part. Okay, for the linear part, you have a same tension here, F. Okay, these two in fact are equal. Okay, what I'm pulling this down is what this will be pulling it, the object up. Similar. Okay, and then you have weight. Okay, then you solve these two separately using their own sum of forces equals to ma. Okay, so for this case, the linear case, very simple, straightforward. Sum of forces equals to ma. I mentioned previously, the force that is in the same direction as the acceleration will be positive, so mg is negative. F minus mg is ma. Okay. This one is a bit more tricky, but very similar to this one. Okay, it will be the summation of torques is equals to some kind of mass times acceleration. Okay, but we don't use mass, we use I, and then we use angular acceleration. I is it has its own formula lah. I think it's mk square, which you will be able to find, but nevertheless it is some kind of a mass. Okay, now the same thing, my motion is clockwise, my acceleration is clockwise. The torque that is in the same direction will be positive. The torque that is in the opposite direction will be negative. Okay, so for this case, applied torque will be positive. Friction torque will be negative. Okay, since it's going against the motion. Okay, we have one last torque. Okay, and this torque is caused by the tension. Okay, because there is a mass times a distance here. Okay, and this is the distance d. Okay, the radius of the shaft is your d. So F times d is the one last torque we need to add here. But is it clockwise or anti-clockwise? It is anti-clockwise. Okay, so it is also negative, minus F times d. Imagine the tension. Okay, so it is causing an anti-clockwise moment. So equals to I alpha. Okay, so usually you will solve this equation and this equation. Okay, the two accelerations are related such that A is equals to R alpha. Okay, so and one more thing, if A is going up, right, my alpha cannot possibly be anti-clockwise, or else the motion will be different. Okay, and it will not be right. So it must always be at the right direction, like this, like this, like this, like this. Okay, yeah, so this is how they are related. Then with this you can solve your equations lah. Okay, another situation, what if now the object is going down? How do you visualize when your drive shaft is moving the object downwards? means lifting it, putting it down to the floor lah. Okay, so my A will be this direction. Okay, mg is also remains the same. There will always be tension. Okay, so for this case, your sum of force equals to ma. Mg will be positive, okay, because they have the same direction as A. Tension will be negative. Sorry, I should write F over here. F, tension. So the equation becomes mg minus F equals to ma. Okay, is the easy part. Now, the more complex part is this part. Tension will still be here. Okay, no matter whether you are lifting or putting the thing down, there will always be tension here. Okay, direction of motion, since A is down, right, the drum should be going this way, right? Okay, so alpha should be this way. Okay, and since my motion is this way, the friction always resists motion, so friction must be opposite. Okay, TF, friction torque. Okay, the last part is what kind of torque should you apply to put this down? Okay, if the torque that you're applying is downwards, actually you no need to apply at all, because if I let go, it will just go down. There's no need to apply any torque. So that the direction of the applied torque, right, okay, must not be the same direction as the alpha. Okay, because now you're putting things down. Okay, if I want to put things down, I don't need to apply torque. It will automatically go down. Okay, so what you should be doing is I need to have a braking. Okay, as it goes down, I brake. It goes down, I brake. So my braking torque must be against the motion. Okay, so TB should be opposite the motion. Okay, so this is a case for putting things down, very different. Then you do the same thing lah. Sum of torque is equals to I alpha. Okay, TF and TB will be opposite direction, so both are negative. Okay, F times D. Okay, F times D once again is causing an anti-clockwise moment. Okay, so this is the only moment that is same direction as alpha, so this one will be plus, equals to I alpha. Okay, so this is how you form your equation. If you do not form the equation properly, if you do not form it correctly, then you will not be able to solve the problem. Alright, okay, let's go to the next video then.